Hello everyone, this is Yifan Zhang from Indiana University, and I am a final year PhD student. I'm here to present our work, Navigating the Privacy Compliance Maze. This is a joint work between IU, University of Central Florida, and Sun Yat-sen University. So nowadays, most of the leading third-party SDKs are providing privacy APIs to app developers for privacy compliance. So as we shown in the slides, this is a screenshot of a document from UnityS. It's a famous advertising SDK. So basically, this advertising SDK is providing GDPR compliance API if the user chooses to opt out of the private data collection. The app developer should send the false to the university ads so that university ads will stop collecting the user's private data. So what is our research question? So although previous work discussed the non-compliance related to SDKs, there has been no systematic understanding of whether and to which extent the privacy-configurable SDKs enhance the privacy compliance. Let's see a motivating example first. So although the idea of privacy compliance API sounds simple and intuitive, in the real world, the situation can be much more complex. For example, here is the dependency graph of Call app. It's a very popular app that has over 100 million downloads on Google Play. And so this app, for maximized monetization, they implemented in-app ads bidding that selectively displays the most valuable ads from multiple advertising networks using their SDKs, including AppLovin, Creative, and Audience Network. Besides, we can also notice that the advertising network itself can also become an ads bidding platform. For example, AppLovin. Although AppLovin can deliver ads to end user by itself, it can also launch a bidding among multiple other PICO SDKs for the app developer, like UnityS, like Augury, and AdMob. We call this kind of SDK, like AppLovin, as PICO wrapper. So what can went wrong in this ecosystem? So first and the most obvious is important for the app developer to correctly deliver the end user's privacy configurations to each of the PICO SDKs used. And on the other hand, for the PICO wrappers, they must relay the privacy configuration it received from the app developers to all of the other PICO SDKs it integrates with. Besides, the PICO wrapper must also be careful when it decide to integrate new PICO SDKs to make sure all the integrated PICO SDKs are supporting the same privacy law that the PICO wrapper provides. Because in this case, the PICO wrapper will launch all of its PICO SDKs in parallel. So if one of the PICO SDKs it launched does not support certain privacy laws, then the privacy compliance of the whole app will be break. So what do we do in this work? To provide a better understanding of this ecosystem, in this work, we performed a systematic measurement study for a better understanding of PICO SDK's implementation and their usage in apps. So in order to start our measurement and understanding, we first created several general privacy principles for each of the role in this ecosystem. And that is, we created principle for the app developer, for the PICO SDK, for the PICO wrapper. And our principle here are kind of high level and general principle. Like, for example, principle 2, privacy by default, like principle 4, the PICO wrapper must complete the privacy delegation from the app to the individual PICO SDKs. And we use this privacy principle to guide the design of PICO violation patterns. As we can see in this slide is the violation pattern from number 1 to number 3. We will ignore some of the easy and intuitive patterns so that because of the time limitation. And so on the left-hand side is the is our second pattern. So for this pattern, basically we are talking about to detect if an app is forwarding a hard code configuration to the PICO SDK, regardless of the user's true privacy configuration. So although there's no direct proof of the motivation of those app developers made this mistake, from the PICO SDK's document, we can see that if the app developer chooses to protect the user's privacy data, then the app developer's income will dramatically decrease. And on the right-hand side, we have the pattern 3 because some of the PICO SDKs are having specific requirement of the implementation. For example, AppLovin, they require the app developer to call the privacy API before initialize the whole SDK. However, in the wild, we notice that lots of app developer choose to do the reverse. They tend to initialize the SDK first and then call the GDPR, set consent, and other CCPA compliance APIs. So this kind of invalid API usage would also cause the leakage of users' private data. In this slide, we present the patterns about related to the PICO SDK's fault. So on the left-hand side is talking about if the app developer is delivered the correct user privacy configuration to the PICO SDK, will the PICO SDK upload any sensitive private data from the end user to its cloud? So we have a kind of interesting observation for this pattern. That is, we notice that some of the PICO SDKs, they choose to store the end user's GDPR consent in their cloud. And the user's GDPR consent is a Boolean value, it's true or false value. So in order to store the user's consent in their cloud, they have to create an index for each of the user. However, the creating of this index, that index can be used to track the end user, and in that way, storing the end user's GDPR consent in the cloud will very likely causing the violation of GDPR. And on the right-hand side is our sixth pattern. The sixth pattern is basically a design flaw in some of the PICO SDKs. So some PICO SDKs, they choose to create a single variable to store both of the GDPR consent and CCPA consent. However, it's a very common practice for the app developers to call all of the privacy API at the same time. So in this case, if the app developer chooses to set GDPR first and then set the user's CCPA consent, in that case, the user's CCPA consent will override his or her GDPR consent, which will direct the app to be privacy in compliance. So on this page, we are presenting the patterns related to PICO wrappers fault. So on the left-hand side is the uneven privacy support. As we mentioned in our motivating example, if the wrapper will launch all of its integrated PICO SDKs in parallel, it must make sure that all of the PICO SDKs it launched are supporting the same level of privacy compliance as the wrapper provides. Otherwise, for example, in this picture, the PICO SDK will cause the whole system, will cause the whole app to be CCPA in compliance and COPA in compliance. And on the right-hand side is our patent 9. So we call it conditional propagation. This is because we notice that some of the wrappers, they have their own understanding of privacy laws. So they choose to add a conditional check before they relay the user's privacy configuration to the PICO SDKs it integrates. For example, we notice that some of the wrappers are using IP address as a condition. If the user is not in European, he will not be protected by GDPR. However, in most cases, this is not true because it's Android app. Some people will use VPN. Some VPN app itself will use this advertising wrapper or analytics wrapper. So we want to claim that using the IP address itself as a condition to decide whether a user should be protected by any privacy law is irresponsible. And to conduct our measurement, we have a data set. So we have two data sets. We have a PICO metadata. We have PICO metadB and apps data set. For the PICO metadB, we gathered a list of more than 200 most popular SDKs from AppBrain. And after two experts' manual filter, we come up with 65 PICO SDKs metadata, and we store them in a database. And for the apps dataset, we collected more than 48,000 Google Play apps that all of them are updated after January 1st, 2020. And we make sure all of them are available in both the United States and the European. And after our analysis, we find out that more than 24,000 of them integrates at least one PICO SDK. And this is our framework. Because of the time limitation, I cannot provide more details. Please refer to our paper for the implementation details of our framework. This is a framework with a combination of static analysis and dynamic analysis. And finally, to evaluate our framework, we have two domain experts to create a ground truth dataset. We randomly selected 40 apps, and we randomly sampled 10 PICO SDKs. And we let these two domain experts to do the reverse engineering and to mark the data correctly. And then we measured our tool's precision and recall. And here is our result of the measurement. And there are some of the interesting numbers in this table. As we can see, for the patent 4 and patent 5, the number is relatively high. More than 20,000 apps are affected. And that is because some of the very popular PICO SDKs are violating these two patents, causing more than 40% of the collected apps are affected. And another interesting number is on the right-hand side, the 591. So this number is relatively low. It's not because all of the PICO wrappers are doing well. It's because there are still not too much apps are using PICO wrappers. In fact, more than half of the PICO wrappers are having bad privacy practice. Thank you. And here's the takeaways. And my name is Yifan Zhang. This is my website. I'm from Indiana University, Bloomington. Thank you.